Hello and welcome. Wow, you kind of just went all quiet on your own, like, oh, it must be 3 o'clock, we better shut up. That's amazing. Just a bit of disclaimer. Does anyone here come last year and saw my talk on HoloLens? Oh, cool. All right. Because this is not quite, but kind of a continuation of that. So I won't really be talking about much I talked about back then, so that's good. For the rest of you, tough luck. No, I will do a bit of a quick overview in a minute. So I live in Australia, and it's a nice place. I don't know if anyone's been there. Who've been to Australia? Anyone? Yes, one person. Woo! It's quite nice, and we do like visitors. Tourism is a big part of Australian economy, which is why we have appropriate warnings for our visitors. Now, has anyone here ever seen a drop bear? Right, because if you said yes, you would have been lying, because you would have been dead. They mainly attack tourists, which is why we kind of put these warnings up. For some reason, they understand what a tourist is. Now, I realise it's summer in Oslo. Yeah, ish. Have anyone ever experienced an Australian summer? Right? Yeah, a couple of people. Because it kind of looks kind of like this, right? And you just get used to it. I mean, I'm Danish by birth, so the first 4 days of over 40 degrees is kind of annoying, and then you just kind of get used to it, right? So another thing that most people don't know about Australia is that we have snow. No, this is not Norway. This is about 90 minutes from my house. This is what it looks like kind of right now. Anyone knew that? Hey, you can go skiing in Australia. It's kind of cool. So we have everything, including drop bears. So today, I will go through some of these things. So I'll just do a quick overview so that we know kind of where we are, get a common starting ground, okay? I'll talk about something called the Holo Toolkit and how that can make our life a lot easier if we do want to develop for the HoloLens. We'll talk about gestures and more sort of in-depth gestures. Voice commands, which is kind of a crucial element that people forget about, as is spatial audio. And then we'll talk about spatial mapping, and then finally testing, because no one likes doing testing. See, I'm right. No one said, yes, I do. And testing for HoloLens is a little bit different. It's not that simple, because we can't really do unit tests and that sort of stuff. So I'll show you kind of a few tips and tricks on how we can test for HoloLens, which is as important as any other software application. Okay. If you have questions, and I know Norwegian audiences love to ask questions, it's your favorite thing, please just raise your hand or yell out, or poke the British guy next to you or the Australian across the next aisle, just so they can ask the question for you, okay? I'm going to keep going at you until you start asking questions, by the way. And if you are on the Twitters, if you follow me, I'll magically tweet more information about what I'm talking about as I'm talking about it, okay? I have an implant here that goes straight into Twitter. All right, so a quick overview of what we're actually looking at. So has anyone here developed for HoloLens? Has anyone built just anything, basic app, whatever it might be? One person, two people? Okay, so that's like 2 or 3 people. Okay, cool. This is probably good, then I go through this. There are 5 main things we need to know. The first one is gaze. Gaze is kind of where you look. It's not your eyes, it's your head. Right, so your head is your mouse cursor, which is very confusing to start with. But as you move your head, there's a cursor in front of you in the HoloLens experience that kind of moves with you, right? So that's called gaze. It's how you select things. It's how you look at things. It's how you interact with certain objects or whatever it might be. The next thing we have is gestures. There are essentially 2 gestures. One is bloom. It's kind of like this. Kind of like a flower. And that closes the app or it brings up the start menu. And the other gesture is like this, tap. Right, that's the only 2 you need to know. And this is tap, right? This is not tap, this is not tap, that's not that, it's that. Just that, simple. Don't try and make it harder than it should be. The third thing in the input, which is called GGV, because it's gaze, gesture, and voice, is voice commands. And it's incredibly powerful. It's really, really, really accurate. Because most people will maybe not have bought one of these because they're stupid expensive still. So you are stuck with the emulator. And the emulator works just fine, but the voice recognition is through the mic on your computer. So it's not a representation of how it works in this. The voice recognition of the voice commands on the HoloLens is incredible. It's the best I've ever seen. So that's something to bear in mind. And it's part of your input, right? Because it might not make sense to have, tapping gets boring real quick, let me promise you that. So you might want to have gesture, voice recognition or voice commands. You can always say select, it's the same as tap. You can always say something that's on the screen, it's kind of like see it, say it. So if there's a command that's a label under a button or under say remove a window, you can just say remove. You don't have to tap on it, right? And it's a nice shortcut. And then you have custom commands as well, which we'll look at in a little bit. The fourth thing is sound, spatial sound. It's using something called the head-related transfer function, which we'll get to in a minute. But sound is really important, and it's very easy to implement and very hard to get right. So we're going to spend some time on this as well. And of course, we have spatial mapping. This is what makes HoloLens HoloLens. Without spatial mapping, there wouldn't be any mixed reality experience at all. Okay? So we'll look a lot more of that as well. And yeah, I know you're kind of sitting there going, yeah, whatever, just show us the thing working. Am I right? Yeah, you're going to have to wait. Yeah. Okay, so that's the fundamentals of HoloLens development. There's those 5 things you need to have in your experience for it to make any sense. To be convincing, to be engaging, to be immersive. Anyone got questions? Okay. God, I will get questions. You're not going to get out. I'm going to close the doors. Okay. Now, the first thing I want to talk about is this thing called Holo Toolkit. And the Holo Toolkit it's like your best friend when you make HoloLens or mixed reality applications. It's essentially, it is a GitHub repo, as you can see there. There's one for Unity, one for Visual Studio. So in case you hadn't, so I didn't mention that, but you use Unity to create your model, your scene, and then you export that into Visual Studio to do any kind of coding and deploy it. So that's kind of the workflow. Holo Toolkit has come from Microsoft. So it's an open source project now by Microsoft. And they used it predominantly for these 2 games. Now, I keep saying this anywhere I can that I don't think HoloLens is a gaming device at all. I think it's for industry, it's for education, it's for healthcare. But the best mixed reality experiences we have right now are games, right? And these are 2 of them. One of them is called Fragments, and it's where you're a memory detective that needs to find memory clues, and it essentially maps your room using spatial mapping, and it shows clues as audio, visual, voice, whatever it might be that you would expect in a normal experience, and they're memory fragments. That's why the game's called Fragments, right? So you see memory fragments that you need to then deduce and decipher. The other one is Young Conker. Does anyone ever play Conker back in the day? The little squirrel? Yeah, that's good. There's a couple of guys here. Conker is a little squirrel guy, the one that's jumping around there. And he collects gold coins and he does stuff and he solves puzzles. But in this case, he jumps around your living room. Right? So he'll jump on your furniture and he'll chase coins underneath your couch and go behind everything and he'll come out the wall. There'll be a zip on the wall. He goes zip, and he comes out and it's really cool. Right? So how do they do all this? This is where the Holo Toolkit came in. So they realized that they needed certain things over and over and over again to build these HoloLens applications. When you do spatial mapping, you just get a grid. Now, we'll get a lot more into spatial mapping, but you just get a grid. It doesn't tell you where your couch is. It doesn't tell you where your floor is. It doesn't tell you where your ceiling is. You've got to figure that out yourself. So the Asobo studios in Paris, I think in Paris, but certainly in France, and Microsoft came up with this toolkit. They can identify walls for you, can identify couches, based on saying, there's a flat surface with another flat surface, that must be somewhere you can sit, for example. So in the Fragments game, the commander-in-chief or the top lady will come in and sit next to you on your couch, right? Or the guy will, I heard a story the other day, I didn't know this would happen, but they were playing Fragments in an apartment where they didn't have any chairs or sofas where they were playing it. But they had this kind of kitchen bench thing that they would normally just kind of jump on and sit on, like you do. You sit there, right? That's what she did. This character came in and jumped on this thing to sit, because apparently that was the only place you could sit. So it works really well. There's a few more features in it. There's a project setup. So if every time you create a new HoloLens application, there's a bunch of stuff you need to go through. Like you need to set the background as black because black is transparent. That's where you don't render it. You need to set the virtual reality capability. There's a whole bunch of things in settings and it's like a checklist and you forget half of them all the time. So they just made a little shortcut to set it all up for you. There's lots of tooling, like I said, around spatial mapping, how to deduce what things are. There's a sharing library. So part of the story with HoloLens, which is not widely used because you need more than one. It's expensive enough to buy one. But there's a sharing experience where you can share experience or holographic experiences through a server. And there's a bunch of tooling that allows you to do that easier. And then there are 100,000 million scripts-ish. I didn't actually count them. There's a lot of scripts. And these are scripts that allows you to do all different manner of things, shortcuts to something people have found out how to do. It could be, putting cursors on the screen, putting other visual assets on the screen or audio or anything like that. There's lots of different kinds of assets and scripts in there. Okay. So, maybe we just have a look at how it works, eh? So, I have Unity open here. Now, generally, has anyone ever seen Unity before? Okay, excellent. There's a few people. So, and this is the point where you say, I can't see Unity, okay? Come on, jeez. Hey, there we go. Okay. Jeez, people. So Unity is, for those of you that don't know, is a game creator, game design engine. It's used traditionally for 2D and 3D games because holograms are 3Ds, HoloLens experiences are 3Ds. This has become the de facto tool that you use. So you can use other tooling, but you will probably end up sitting in the corner rocking because this is so integrated now that it's almost impossible to use anything else. Okay, so the thing you would normally do is you go under Assets here, you import a package, and you just say Custom Package. Before this, you would have downloaded this Unity package from the GitHub repository. And this I've handily placed here on the desktop, Holo Toolkit.Unity package. Now, I'm not going to do it now because it takes a couple of minutes to import and everything, so I've already done it. But it is, 96 megabytes of things that you might want to use. So I've imported it here. It gives you a new menu up here. Now, it's a little bit small, perhaps, but I can't make it any bigger because Unity. So I have configure buttons here, apply HoloLens scene settings. So that's what, if I click on that, it'll say move camera to origin because the camera in Unity is your eyes in the HoloLens world. So normally if you're building a game, you'll have the camera sort of pointing at your player so you can see it from the outside. It's kind of third person. HoloLens is always first person because if you, I've tried it, if you place the camera a meter to the left of where the user is looking, ooh boy, they're going to throw up all your living room. It's very, very confusing. Camera clears to black, so I said transparency, update near clipping plane. So there's something called near clipping. How close do I get to holograms before they disappear, before they're not rendered anymore? The default in Unity is too close for HoloLens. It's like they're in your face, which may be okay in some scenarios, but by default certainly isn't. And then update the field of view, and you can apply those and so on. And these are things that you will normally go and spend time figuring out which menu was it in, because you only do it when you start a new project, right? You configure something else, project settings, target Windows Store, UWP. This runs Windows 10, by the way, in case you didn't know, which means it runs Universal Windows Platform apps, which are the very, very clever apps that no one gives a shit about. Okay? This is also what my Windows phone runs. Yes, I'm one of them. But it's important because it allows you to build stuff that runs across Windows 10 platform. And you target and you set and other settings that I won't go into now. So it has that. The whole toolkit has that, which is quite cool. It saves you a lot of time. But then also down here is all of these assets, massive amount of assets. So I've just chosen scripts and cursor here. For example, if you want to have a cursor, you've got to build it yourself. Where the user looks in your app doesn't come free. But it almost does because there's scripts for it. So you can have a mesh cursor or a standard cursor or an animated cursor. It comes with all of these tooling for free. And you can see on the right-hand side, you can see the script that you otherwise would have had to write, right? So it might not fit exactly your purpose, but you just adapt. But it saves you heaps of time. It's like if you're building anything for HoloLens, use this. Okay, any questions for Holo Toolkit? Not all at once, please. Oh, gee. Really? So you know everything about it now? Good. Okay, yes!
It's not about Unity. It's the HoloLens.
Sure.
So you're saying it's running Windows 10? Does it mean you're not, it doesn't require any wires going to a computer?
So yeah, so the question is, it runs Windows 10, so is it not tethered? I guess is the question, yeah? So no, there's no wires coming off it. If you've ever done a virtual reality experience like Oculus or something like that, you need like a nuclear reactor next to you to run it, right? It's massively power intensive, computing intensive, and there's a big plug that goes into your head. There's none of that. This is it. This is as it comes. Fully computing device. Yep. See, I got a question. See, ice broken. Yes.
So you downloaded like a 90 megabytes package.
Mm-hmm.
Is there some sort of package manager?
Good question, actually.
Or something?
Yep. So I'll see if I'm not sure I have internet connection. But there is. So is there a way to download this easier? That package, that Unity package, doesn't come out of the blue like that. I think it's Holo Toolkit. If you search for Holo Toolkit Azure websites, my good friend Jimmy Engström from Sweden has built an automated thing that just updates it. So every time there's a push to a new version on GitHub, it pushes out the Unity package for this, and you just download it. So there's not an actual package manager. You probably could set up some sort of build script or something if you wanted to. It's not difficult. All right. So that was Holo Toolkit. Ta-da. Let's see if that works. All right. The next thing is gestures. So we talked to gestures as bloom and the tap. But you can extend the tap as well. So you can do a hold, which is hold your tap, and you can sort of hold it. Right? That's a different event that triggers in the framework if you hold it, if you don't let go. You can do a manipulation. So that's, again, kind of hold and then start moving in either vertical or horizontal 2D plane, and that becomes a manipulation. And then you can do navigation, which is, again, a hold and kind of a 3D navigation. Like if you had a joystick in 3D cube type thing, right? So you can move it in all directions. So those three also come for free. You get those out of the framework. And then usually the question I get is, ooh, can you build your own gesture? Yes, you can. Please don't. There's two reasons for that. One is that you need the raw input of what the fingers are doing, and then you need to decipher that yourself, and that will probably drive you insane. I'm imagining it's a bunch of mathematics that I have no idea how to do. The other thing is that how do you educate your user and saying, hey, there's a new swipe gesture or a new whatever gesture it might be. How do they know? And why would they know? Because every single other HoloLens app will only have tap and bloom and hold and whatnot. Right, so yes, you can. I haven't done it. I don't plan on doing it. But yeah, you can. So, okay, let's have a look at gestures. Oh, you can see it still. Very good. So, this is a Microsoft example from their second level tutorials called Astroman. He's the guy that was on the opening slide as well. And Astroman is a guy that floats in space. There you go. Very exciting. It has a bunch of code that comes with it. I'm just going to show you where it implements the different new gestures that you might not have been familiar with. So in here there's a gesture manager. And these are scripts that are attached in Unity to the different elements, right? That's how you kind of make Unity talk to your scripts. I'll just go here, see it? So I have the script here, I just grab it and drag it up to whatever object I want it to put on, and I'll just let go. And that's it, it's now attached, right? And then that becomes a script that's initialized when that object is initialized, and it's refreshed when that object is refreshed, and so on. So this script is attached to a part of Astroman. And in here we have I'll just go down a bit. On awake, so this is when we're awaking Astroman. We're setting up a bunch of different events. And this is my aim with this is just to show you that it's not very scary. If you've done any kind of C# development, this should look quite familiar. They're just standard events that you bind to, or that you attach an event listener to, right? So if I just close that and show a bit more. So we have a tapped event, which we knew before, so that triggers this event. We have a navigation started event, and so on, right? If you go to one of, say, navigation updated events, I'll just hit F12. Ooh. And JetBrains goes, yep. Didn't work? Come on. There we go. Oh, that was nice. That was useful. I think someone screwed up my shortcuts. So we go to implementation. Oh, that's lovely, isn't that? Okay, I know it's down here somewhere. So here, navigation updated event. All we're doing is that we're rotating Astroman essentially, right? So we're setting is navigating to true, so we kind of got a flag saying whether we're navigating or not. And then we're just setting this navigation position to the relative position, which we get from the event, right? So the event is telling us where we're navigating to in 3D space. So it's tracking all of that. We're just getting a Unity object, which is the vector 3 object. And that's the relative position we just set as that. This is how easy it is. Like once you get your head around some of these object types and constructs, there's really not a lot to it. The hard thing, we'll get to that. That's designing the thing. Implementation is not terribly difficult. Of course, I say that now, and you start approaching and go, oh. But there's always things that kind of is out of the ordinary. But generally, there's nothing magic to it. It's C# code, and it looks kind of like you would attach events to WinForms, right? Should I say that? WinForms? There you go. So that's navigation, and all of them are like that. They have if you can continuous and hold, there's a hold start, hold update, and hold end or cancel. The same with navigation and manipulation. Anyone think that's hard? Questions? Anything? Because it's kind of simple, and I'm building it up, and there wasn't much to it. All right, let's have a look at Astroman and how he does it. Now, the emulator is a little bit small because the resolution on my computer is quite large, and because Windows 10, DPI, stuff like that. If I press the Start button, or Windows button here, it brings up the Start menu. And I'll show you that on the HoloLens as well. And that has, I've deployed a little app in here called Model Explorer, which are Astroman. Well, that's our Astroman thing, and we'll place it there. So that's the emulator, if you hadn't seen that already. The emulator is the closest you get to a physical HoloLens device without owning one. And that seemed to have crashed. Let's try again. It has spatial mapping. That's not working now. It has spatial mapping. It has network indication. It runs Hyper-V, so it's kind of its own machine. It works almost the same as a HoloLens, but of course it's much more fun to have a real one, right? You can load rooms into it that you've mapped with a physical device. You can log into your Microsoft account. You can deploy things to it. It works kind of like a real device. Let me just try and deploy that again. Any questions on this? Emulator, anything? Yes!
So in your event handler, you said you're getting the position. Are you also getting the object that you're trying to interact with?
Yes. Yep. So, so you mean in this case, Astroman?
For example.
Yeah, because the script is attached to him.
All right.
Yeah. So you get that's the model you're kind of interacting with. Yep. Okay. Let me just try this again, and if it doesn't work, then you have to take my word for it. Okay. No, it's not going to work. I don't know why. I'm not going to debug it right now. It worked about an hour ago. Okay. It's not that interesting. I'll show you on here anyway, so it'll be better. Okay, so the next thing we want to talk about. Come on. Go. There we go. Is voice commands. And as I said, the voice recognition on this is really good. Really, really, really accurate. It's not perfect. Absolutely, it's not perfect, but it's the best I've tried on any device. You can do pretty much anything with voice commands. There's a lot of, how should I put this? There's a lot of easy ways to make it not work very well, but once you get it right, once you get the speech design right, you kind of, yeah. This is the hard part. The speech design is what I struggle with a lot. Because how do you make your users aware that there's a voice command? How do they know to say a thing, right? What actions can you actually take through speech? Because how do you know? How do you figure out, is it everything? Like, is it every single tap thing you can do? Do you want to do that as speech? Or are there things you can only do through speech? How do you define those? And you need to really think about these things. Is speech input a good option for completing a task? Like, does it make sense? It does if it saves you, 6 taps or whatever. Then it's a good thing. How does a user know when speech is available? Obviously, there's say it, see it, say it. So if you label things and they can see it, they'll be more inclined to say it. But you need some sort of tutorial or training mechanism to let your users know, right? Is the app always listening? Because by default it is. So are you going to have voice commands that only work in certain circumstances? Then you need to kind of think about that. What phrases initiate an action or behavior? Because it's really easy. I do a workshop on HoloLens as well, and we build this thing where you shoot balls and blocks and they fall down. And we implement voice commands, and it's very, very easy to think that you should use shoot. So you just go shoot, 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 and it goes shoot, 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 shoot. But it's too short, because different dialects say differently, like the Norwegian English is different from the Danish English and so on, or the English English, or the real English, which is Australian. And you're much more likely to get a good response if you say shoot ball, because it's 2 to 3, 4 syllables. It has context, and the voice recognition will pick it up much easier. What's the interaction dialogue? Because sometimes you might want context. Something can only happen if you've done something else. Again, it's an education issue, but it's also a programmatic issue, right? If you need context between your voice commands. And is network connectivity required? I always put that on there because as you develop, you always have network connectivity, and then suddenly you do some voice command that requires it, and it goes boom. No, the HoloLens does not require connectivity to do the voice recognition, but your command might do something. Okay, so I'm just going to give you a quick demo here. Here you go. Now bear with me for a second while I open a different solution that will work. And we'll deploy that to the emulator. Now this is the other tutorial that Microsoft does. It's called origami. This is where you start. It's kind of the starting point. But I'll show you the voice command in here because I know this one works. I hope. And this is kind of maybe an hour and a half worth, maybe if you just go through the tutorial real quick. And that gives you a good understanding of how you start building for HoloLens. It's a little bit rudimentary, but that's okay. Ooh, that's big. So, let's deploy this sucker once it comes up. Has anyone does any kind of voice recognition work on, say, Android or iPhone, or like have you ever tried integrating with Cortana on Windows 10? No? Yeah? And experience?
Yeah, it was fine. The hard thing is making your user say a specific sentence.
Yeah. Yeah, again. So I was just this gentleman here says he's done it with Cortana, but getting someone to say that specific sentence you need is hard. So the education part of this is really difficult. All right, I think we're here. So let's see if we can deploy it to the HoloLens, or to the emulator. So we're going to start up the emulator again, or load it on there. So this is origami, hence paper folding. It's very exciting. I'll see if this works. It should work with the mic on my computer. But let's see. What else can I say while we just wait on this? So this was kind of a, plan B here because the other one didn't work. Something like Cortana works as well. If you've ever done any integration work with Cortana, I've done a couple of presentations on it, you'll find that it's exactly the same. Like you need voice command definition files and stuff like that to integrate your HoloLens app to Cortana, and you can use Cortana to launch your app and everything. Okay, so we got origami on here. Just place that there. Wow, it's all broken. I'm guessing the emulator has done something wrong. Okay. Is it often a problem? It can be. I mean, ideally I would restart it now, but that would just bore the hell out of you because it takes a little while. You're just going to have to take my word for it. I'll do voice commands when I put this on in a second, so it's not like you're going to miss out. But yeah, the emulator is reasonably stable normally, and I started it up and tested it all before I got up here, obviously, and now it doesn't. So, yeah, I can't do anything about that. Let's talk about spatial audio, shall we? And then we'll get to the cool stuff. All right. So spatial audio is one of those things that get neglected because audio is hard. Although for this device, it's using something called the head-related transfer function, and it's really easy. Like all you have to know is this. There's not much to it. This is what I found on Wikipedia. It's a bunch of mathematics that I have no idea what it means. I think on the right there's this circle which recommends R1, R2 is the ears or the head of a person, and then the sound is that green line, right? But that's as far as I got. What it means is it's a binaural algorithm that measures how sound should reach your ears, left and right. So if I have, say I'm wearing the HoloLens, and I have a hologram over there to my right, the sound I hear will appear as if there's sound to my right. It's really accurate. If I turn my head and look at it, it'll appear as if it's in front of me, right? So the sound is in super sync. Like it's very, very accurate. And it's very, very convincing. But you can screw it up, no problem, if you want to with your audio design. I like this slide much better because that kind of shows what happens, as in you don't have to do any work to implement head-related transfer function. You just drag an audio file onto your 3D object in Unity and hooray, you're done. Which is why designing for it is much harder. It's again like voice, we got to talk about design of audio because this is important. Ideally we already know how to implement it now because it was the talk last year. There are a few different elements that you need to take into account. Grounding. So grounding for audio, it means that the audio that you apply to something should tell the user kind of where it is, right? He should be able to see a hologram, and if you can't see him, you should still be able to cognitively know where it is. That's the idea with grounding. So if I'm, got a Safari HoloLens experience and there's a line over there, I want to know the line there when I was not looking at it, right? I want to know. So the grounding of that with audio is very important. User attention. If you have, say, in a game, again, I come back to games because they're easy to explain, you need the user's attention to look at something, to a clue or an enemy or whatever it might be. You can use audio to guide them, right? You'll instinctively look at a sound that's over there when you can't see it. That works very well. Then you have immersion, which is a big part of this, obviously. You want realistic, physical sounds that match the object that you have to make the immersive experience as convincing as possible. And then you need interaction design. So you need to understand how people interact with audio. And this is a whole other talk. Audio is terribly complex and really difficult to get right. Something that I personally just don't like, I loathe it, is background music. Especially on these HoloLens apps, because it's there all the time. You can't escape it, right? And it just gets on your nerves, and it's loud, it's overpowering. I just can't have it. So to me, something like background music is just no. I'll have environmental sounds, sure, a car passing or whatever it might be, that's fine, or wind blowing, but please don't do that with the music. It just gets on people's nerves. You say, oh, that's a nice tune. Yeah, for 2 minutes. If you do it for 2 hours, no, it's not nice. It's just really, really annoying. Audio tips. Use gaze mixing, which means highlight objects. When you look at objects, give them a sound. It's nice. We don't have haptic feedback, so if you look at something and make it go boom, people kind of know, oh, I actually am looking at it. Just some sort of feedback. Audio. Whoops, sorry. Didn't mean to do that. Audio haptics is what I just said. Sorry. And then again, immersion. You need these sounds to make people feel like the experience is convincing. You want to convince people that what you're showing them is real. That's the whole idea. That's why we can see the real world through it, right? Ideally, they wouldn't even know that they're digital assets. Of course you know, but the experience is like you forget, and they just become part of the real world. That's your aim. Okay, questions on audio before we get to the really cool stuff? Yes?
How difficult is it to take into account surroundings, like closed doors or big holes that echo otherwise, things like that?
For audio?
Yeah.
Well, the audio is only on your ears, so it doesn't actually do that. So, sorry, the question was, how do you take into account if there's like an echo normally, like with a closed, open door and sound travels and all that sort of stuff? You can't really do that unless you program for it, maybe.
I mean, like sound sources behind closed doors in your virtual reality.
Yeah, so if you close the door, does it muffle the sound? It doesn't yet. Like, it doesn't have that capability yet. But that's a good point, because that is part of what I hope is being worked on. Because we know when the door closes, right? Because we've got spatial mapping, right? We know where things are. Now, this is the cool part. This is kind of what I was, rushing towards. Well, not really. Spatial mapping is a bunch of triangles, a whole lot of them, like a lot. I did a mapping of my living room / kitchen, kind of, combined area type thing, and I'd spent maybe 15 minutes on it, just walking around, looking at everything, and I exported the model, and it was about 400,000 triangles. Pretty detailed, right? It's not, like I tried in January, I tried mapping a toy car, actually, with Steve that's sitting over there. That didn't work. That becomes a blob, right? It's not that accurate. But it's accurate enough so I can easily see where everything is. And I'll show you in just a second. So there's a few different things you need to know about spatial mapping and how you use it. Because if you don't have spatial mapping, you have not got a mixed reality experience. Simple as that. And the reason it's kind of glazed paths in comparison to the other 4 elements, gaze, gesture, voice, and audio, is that this kind of almost comes for free. Like, you're not meant to understand how to calculate a 3D model or anything like that. But it does allow you to do something like placement. So placement of things, making them real, making them sit on a table. Like if you have a vase of flowers, you put them on the table, right? You can place things on surfaces or on the wall, like here. You can put your Netflix view on the wall and resize it. You can place things around. Occlusion, which is a really fancy way of saying hiding stuff. So you can, where couches are, you can have things run behind the couches, underneath chairs, on top of chairs, whatever it might be, right? Occlusion can hide part of a hologram. And you can see that quite easily if you place something, like, the hologram app, you place something behind a chair or something, it disappears when you can't see it in real view. It works very well, and it's part of this convincing experience, right? Oops, sorry, other way. Whee! We have physics. We want to make sure that models look like they would behave in the real world, right? This whole thing of ragdoll effect and all that, it kind of just detracts from it. Like, you don't want to have over-exaggerated physics, or, well, maybe if you're doing a moon landing kind of experience, yeah, maybe you want to have people jump around funny. But it's unlikely. So make sure that the physics of this is adhered to, and you apply appropriate, laws of physics to your elements, because the spatial mapping will allow that. Navigation, as I said, you can run around. Conker exactly does that. He runs around your living room, he runs behind your furniture, he jumps on your chairs, and he goes everywhere because he knows exactly where things are. And I really want to show you how this works. So, okay, let's have a look. So this is the developer portal. Looks like this. And now I'm going to look like an idiot. I'm going to put this on. It's not a good look. All right, so give me 1 second while it just fires up. So, it says trying to map your surroundings, and I've now got a start menu. So let's close that. So if I map here, so I can tap anywhere, and it'll kind of automatically try and map the area, right? I'm just going to go away from the light a bit because it gets confused with the light. There we go. Okay, so if I do that, front row, I'm tapping on you. Ooh, you like that? Yes. If I go to the 3D view here, you can see this thing in here. It moves with my head, right? So that's me. See? Yeah, there I am. So I can zoom in on me. Ooh, out, in, here we go. And that's me again, right? So I'll look down from above a bit, and then if I click update here, magic happens. Look at that. There's the model I just made. Right, so I haven't mapped very much. So if I just spend 2 minutes, or 2 seconds, just going around here, because the range of this is about 5 meters. So I have to kind of move a little bit towards people, and then eventually we'll have more people mapped. None of you look like a couch, apparently. No? Okay. And I just click update again, right? And again, so now we've got a bigger model. And this is now 24,000 triangles. So 24,000 different elements for this. And this is what you get for free. This kind of, it's not instant. I guess it remaps everything sort of every 10 seconds or so without me doing anything. So I move over here, it should kind of, tap thing. There we go. And this is kind of what you have to build upon. So this is why I say nothing works unless you have spatial mapping. Now in here in the tooling, there's a few different things you can do. I could do a first-person view. You can actually see what I'm looking at, which is nice for testing things. See, there's my computer, obviously. And there's something called spatial anchors, which is how you anchor elements in the real world. This is probably a good point just to explain how the coordinates work for this device. And I'll show you a lot more of this in just a minute, don't worry, you'll see. I'll shoot up shit and stuff. So for virtual reality, you have one coordinate system. If you've ever done anything for virtual reality, you kind of live within this coordinate system of the world. That's where you place stuff, you know exactly where everything is, you can place things in relation to each other and all that. We're not that lucky with, it moved out. We're not that lucky with HoloLens, right? Because we don't know exactly where we are. It has to map the space first. So we have one coordinate system, so 3D coordinate system, for what the spatial mapping is. But then, because it's not 100% accurate, what if I place something on the chair here next to you? You know, say Conker sits there. I need to make sure that Conker keeps sitting there next to you as I move. If I move around and the character starts moving or fluttering, the whole experience is out the window. It looks like it's not real. So in order to do that, you place what's called spatial anchors on your elements. And they anchor the object's own coordinate system to the world coordinate system using the spatial model, right? I'm glad I didn't have to program this part because it's very complex. But it means that you have physical objects that you bind digital objects to. So they stay with that object. And this is really important. It's really important to make sure that this works correctly. And that's kind of what they've spent 5 years doing. Because as soon as you have a character, as I said before, that starts, drifting or flickering or doing anything that doesn't look real, then you lost them, or you make people throw up, or even worse. Right. Any questions for spatial mapping?
So you can derive objects from this model.
That's a good question. So you can derive objects from this model. Yes, you can get that data out. The Holo Toolkit allows you to do a bunch of these without you having to code it. So that's where's my walls, where's my floor, ceilings, furniture, doorways, stuff like that. But yeah, you can. I mean, it's hard to figure out where a person is because they always look different, right? There's different sizes, sitting, standing, leg over one other leg, and all that stuff. But yeah, you can. Yes.
Is there any interaction with GPS?
Is there any interaction with GPS? I had this question this morning, and I suddenly wasn't sure. I don't think there's GPS in it, because I don't see why you would use it. The thing is, though, if I place a spaceship in here, and the model doesn't change, the room doesn't change over the next 2 months, I come back, the spaceship is still in here. It'll know where that was, right? It has world anchors, which is part of Unity. But I'm actually not sure if that's GPS. I don't think it does. Anyone else? Yep.
If you're sharing views with two, do they communicate their work model with each other?
If you're sharing the view with two HoloLens, they don't share the 3D model, as far as I know. They share the experience. So to do a sharing experience, you need to have a server that all the HoloLenses talk to. And that server kind of distributes the experience and where people are as well. And I have not tried it because, again, it requires more than one HoloLens. But I've talked to people that have done it with about 8 people, and it works really well. Yes?
Is there any real-time updating of the environment, or is it static after you have mapping?
So is there a real-time update of the environment, as in, is there continuous mapping? Is that what you're asking? It's not live, because I'm guessing the battery would go just drain really fast, but it's something like every 10 seconds, 20 seconds maybe. If you sort of calculate every 20 seconds, you'll probably be all right. But it's just also why sometimes it happens that when people walk past you and it maps right as they walk past you, you get this sort of ghost effect, and it's mapped something that's not there. So that does happen, yeah, but it's not 100% live. Gee, you can ask questions. It's good, yes? Is there a limit to the size of the spatial mapping? Maybe memory. Not that I know of. My house is reasonably sized. It's in country Australia. We just build them bigger. That was no problem. That was about 500,000 triangles to 400,000 triangles or something. It's quite large. But I'm sure there is a limit. I just don't know what it is. All right. Cool. So, before we get on to the testing, so the real cool thing, which I'll show you, we'll do the testing. Because no one cares about testing. You're supposed to say, yes, I do, yes. Jeez, people. I know it's Friday afternoon, I just want beer as well. Testing in HoloLens is a bit peculiar. It's a little bit interesting because it's not like testing normal software, 2D software. If you test your web app, or you test your libraries and you have unit tests, integration tests, and they all run and all that. You can't quite do that. Yes, you can unit test your business logic, but what about the actual models and everything that you do? So there's another set of testing, which is called environmental testing. And this is, I would say, equally important. Something like it doesn't do well in sunlight. It's not really an outdoor device because sunlight kind of just screws it up. UV and UV makes chaos. That maps with UV, sunlight is UV, doesn't work. So you want to mainly do it inside, but something like, what about a dimly lit room? It doesn't work very well in complete darkness, but a room like this is really good, right, except for the lights going, the bright lights. So you've got to test that, dimly lit. What if you have red light? What if you have really, really bright light everywhere? Whatever it is that the environment is that you might want to use this app in. Sound, ambient noise, spatial audio. Make sure that you actually can use the spatial audio efficiently. I would really emphasize the sound testing. Users, they'll move in mysterious ways. And you get short people, tall people, get people with 4 fingers. I don't know. No, people are different, right? And they use it in different ways. So make sure you put it on different people's heads and get them to move the head differently, up and down and sideways and everything. And then the physical environment. Because we live in the real world, right? We don't have a virtual reality world where we can, make everything neat. It is just the real world. So what about curved walls? How do you deal with curved walls? Is that going to work? What if you have a flat thing that needs to sit on that curved wall? Is that going to look ridiculous? All these sort of things that you don't have during development, you really need to take care of in testing. And then there's a really cool tool that is relatively new called perception simulation. And I'll give you a quick demo of it, but it is essentially taking over either the emulator or the real device, you can use it on both, and simulating the perception of the user. So what the user is doing and and moving, how they're moving and what they're doing. So I'll show you just what that looks like, because this is a really neat tool. And I have still not seen anyone use it properly, or for any apps, but I could be wrong. So let's go to our perception simulator here. It's really quite simple. You import a couple of DLLs here. There's a perception simulation manager DLL that needs to be part of your project, not a reference. And then you have a couple of references here, the perception simulation manager interop and a perception simulation rest. The interop is so you can communicate with the device. You insert the device IP, which is from the emulator in this case. And let me just check, because the emulator does change once in a while. So we'll just make sure that's the right one before we do anything. So I click on the tools here, I can look at the network, and I can see that my IP is that. And that looks a little bit different, doesn't it? 221.218. See, it's different from that. So we'll just, I couldn't paste it. Oh, there we go. So we paste that, and now I have a access point to my emulator. I don't need any credentials for the emulator. It's just open because it's on my machine anyway. And then if I scroll down here, we set up a bunch of steps. So this is manager. So we get the manager of the perception manager. Human right hand perform gesture. So essentially, I'm doing a gesture, which is home. I do that twice, and then I rotate my head, so I'm looking in some direction. Then I perform another gesture, finger press, finger release. That's a tap, right? And so on. And that's all. You can do this. What this means is that you can do the exact same thing over and over and over again, which you can't do with a human, right? Because you can't do the same movement twice. That's impossible. So this is a really neat tool for testing your app with a predefined set of actions and gestures. So if I run this, I'm going to be quick though, because it's going to fire up a console app. Give it a sec. So, okay, and go. It brings up the massage. I'm not touching anything. Take start menu down, moves, taps, and so on. Right, you get the idea. It's really easy to use, and you can use it on the physical device as well. Then it takes over the input that you would normally give it, that would come from you. And that's it. Now we're done. Very simple thing, really, but really powerful. And you can set this up and automate it and run it on some machine with an emulator and whatever you want to do. Okay, any questions for that, for testing? Does it make sense? How? Yeah.
So, if I understood this correctly, it's running like a unit test where you verify that the state is correct after interacting with it. Is that correct?
You're saying, so is there a unit test, or you're saying is there no unit test?
Is it a unit test?
Or is this a unit test? It could be, although you need to set up the start the same every time, obviously. But you could have that as starting the app every time. So you could have it as a unit test, yeah. That's the closest I can find that comes to a unit test. Yeah. Anyone else? Yes.
Can you get your image from the HoloLens on your computer to verify if something happened and so on?
Can I get the image from the HoloLens onto my computer? In what sense? As in screenshot?
For instance, screenshot, yeah.
Can you do a screen? Okay. Not off the bat. You can off the physical HoloLens has a webcam that you can take pictures with, but not really the emulator. Yeah. Anyone else? Okay, you just want to see it now, don't you? Yeah, I know. All right. So the other magic thing that's in this developer portal is, and you may or may not have seen this before. Let's turn it on again. Okay, I'll see if I can get, there should be sound on it as well. If I go to mixed reality capture here, I can do a live preview. Now I need to say that this is sometimes a bit buggy and it will freeze, so please let me know if it does freeze and you can't see it, okay? But this is me, right? There's about a 2-second delay on it, maybe, ish. So let's just do something silly. We'll open up the holograms, I'll put some holograms over there. I'll try and keep my head still, because I can easily see what I'm looking at, but you're going to look like it's all just flaky. Okay, do you want a spaceship? There you go. I know you like spaceships. Yeah. Okay. And here's something I wanted to do yesterday. Oh, sorry. Here you go, Steve. You can get googly eyes. There you go. Isn't that lovely? No, he's got googly eyes. All right, you get. Okay, I'm going to still run past it. You get the idea, right? Now, this is kind of not actually mixed reality because I'm not interacting with the physical environment. So let's do something that is. And this is always... Anyone tried RoboRaid? No? One person? Okay, we just place this anyway. So RoboRaid is probably the best immediate example I have of... is there no sound on this? Sound person, please? You can't hear that, can you? Oh, you can. Cool, okay. All right. So I got to look at a wall. All right, I'll just go over here. Okay. See if we can find a wall. It's a little bit shiny, this bit here. I might just go down here. I'm going to scream now again, aren't I? Yep, sorry. All right. This is very meta. All right. So it's just trying to scan the room now and figure out where I am, right? Oh, it started again. Okay, we can do it over here. I know this is not ideal. Speakers are a bit... Sorry. I'm making a mess out of it. There we go. So now I'm just scanning my environment so it knows where I am. This is always the boring part of a game, is this cutscene intro.
Ready to start.
Alright, so now we can start it. And I can look through the wall as well. Yeah, someone fell on the floor. There it is. So you don't actually have sound, do you? You can't hear anything. No, because it's quite loud in mine. Can we get any sound on it at all? From the computer? There is sound? Okay, I don't know. It's fully on full bore up there. Okay, so now we... what happens is that it loads everything. I'll just comment. How about that? Oh, I accidentally exited it by doing a hand gesture. That's all right. We'll just start again because he's over there. See, he's over there. Just go back into it. There we go. So now it's loading up the shields and it's doing this magic commentary. And now robots are going to come out the wall. So it says brace yourself. And then it'll point to where, see, there, it's going to break. Woo! It comes out the wall. And now shoot these. Choo, choo, choo. You get the idea. It's a little confusing because the room wasn't very good for it. But you get the idea. Does that make sense? That's what mixed reality is. Like it maps the physical environment, right? Ooh, that's still going. That's confusing. I'll just put it here. It maps the physical environment and then lets me play with the physical environment with digital assets. If you're not doing that, you're doing augmented reality, right? Or even virtual reality. So it's really important that this is at the front of your mind when you start building an app. Mixed reality is interaction between physical and digital reality, right? Any questions for this? Because that demo was a little bit meta. Yes?
So, I'm guessing somewhere there's source code is saying that once I find like a flat surface, I'm going to place that thing that broke out.
That's right.
How does that work? I mean,
Yep.
is it possible to look for like shapes that it would recognize? Or
So it's like, how does it know that there's a flat surface there? Because it said look at a wall, right? And as soon as I started looked at a wall that wasn't shiny, again, this is kind of reflection doesn't do well, it found a surface and I could place it there. And that's because, well, the Holo Toolkit lets you do that, identify walls, but you can also do it with the data you have for spatial mapping. Say, oh, if there's, if the triangles are a certain direction, all of them in a certain area, then that becomes a wall. But it will do it in real time. It will keep updating the model as well. Anyone else? No? Was this useful? I just don't get any response.
What's the best prototype software you've seen?
The best prototype software is set for a game. My favorite of these is, so I said, I don't think it's a gaming device, but when you have 5 minutes to convince someone how cool it is, that's a good one, right? If I had a lot longer, there's a company that build, these stairs that disabled people have, these elevators disabled people have on their stairs, right? They go up the side of a staircase and they sit on it and go, comes up, right? And in horror movies, they always go mad and go, pew! Yeah, right. Those, I saw an example for an app where they would map the staircase with curves and everything. They would then model the elevator on the staircase in real time, so the user or the purchaser, the buyer could see it and say, oh, no, actually, I don't want that, or that's too high, or can you make, or whatever it might be. And then from that, they could export the model and build it, right? So the prototyping or the measurements, I'm sure they still measured it, of course, because it's not 100% accurate. But the measures, or the model was there. They had it, they'd go build it and go back and install it. And that, to me, is just like, okay, that just makes people's lives much better. Okay, anyone else? Because there was a hand, was there? No? Yes.
Have you seen it in use in the industry, say for training for engineers that are going to repair something? Or?
Have I seen it in as training device for in any kind of industry? But you mentioned engineers, for example.
For example, say on an oil rig.
An oil rig, it's not that rugged. Like I don't think it would. Like it'd probably fall apart. Like do not drop this. Usually when people try it, it's, break it, buy it. But I could certainly see it. There's an elevator company called ThyssenKrupp, I think, or something, that use it for their engineers. So if you're going to repair an elevator, it'll know what model elevator it is and overlay schematics and everything on it. So yeah, there are people that are using it. But still, it's not widely spread, but they'll come. All right, anyone else? Oh, last one? No? All right, thanks very much, guys. Appreciate it.